To my YouTube channel. Today we are discussing the LeetCode problem, minimum cost climbing stairs. Let's read the problem description first. We are given an integer array cost where cost at any point I is cost of ith step on the staircase. Once we pay the cost, we can climb step 1 or 2 steps. So let's write what are the things we have given. An array cost we have given, and then we have given is once we pay the cost, then we can climb um, either 1 or 2 steps. So this is given. And third thing we have given is we can either start from the step with index 0 or step with index 1. Start from two options to start from, right? So it's not always we have to start from index 0. They have given us the second option that we can start from index 1 as well. Start from index 0 or 1. This is the these are the things which are given to us. So what does this mean, start from index 0 or 1? It means either we are starting from 0 or 1. We don't have to pay any cost. We can just simply start from there, and then for the further, like from index 2, 3, 4, then for those ones we have to pay the fee to go there, pay a cost to go there. But to start from here, we don't have to pay any cost. Output is we have to find minimum cost to reach the top. Okay, so how can we solve this problem? Let's see here. We have given, this is the staircase. Let's see, it starts with index 0. This is the very first step. This is the second step. So as it is index space, we are starting from 0. 0, 1, 2. So let's take this example. Because we have to reach top of the stairs, so top does not mean we have to reach here. It means we have to go beyond it. That will be the top of the stairs. And the cost is at the 0th index, the cost is 10. Here the cost is 15. And here the cost is 20. And the target is, this is the target. We have to reach here. How we will be doing it? As they have given us that we can start from index 0 or index 1. We don't have to pay any cost for that. So we can start from index 0 or index 1. We don't have to pay any cost for that. So let's see, if we start from index 0, its cost is 10. So if we are stepping up any index, we have to pay this cost. At index 0, if we are taking 1 step, we are reaching here. If we are taking 2 steps, we are reaching here. So if we are taking 2 steps after paying this cost, then 10 will be the cost, and we are taking the 2 steps. We have reached here. We have reached here now. Then because we have to go beyond it, the next level, so then to take 1 more step, we have to pay this cost, 20. So it will be 30. 30 is the cost if we are starting from index 0 and we are going at the top. But what if we are starting at index 1? Index 1 says 15 because we have option. We can start from index 1. Its cost is 15. And if we are directly taking 2 steps up here, we have to pay only 15, and then we are reaching the top. So we can start from here, and we are reaching the top. So this is our output in this case. If we are reaching here to reach at the level step 2, so we will think from here now. From the top, what are the 2 places where we can go at the top? We can either go from 20 to the top. We can either go from this step, a step before it, or we can go from 2 steps down there. So either we can jump directly from here to the top, or we can jump from this step to the top. So these can be the 2 options how we are going at the top. Either we are climbing 1 step, or we are climbing 2 steps. So that is a possibility. So if we are climbing this step, 20, climbing from here, Then we have to find, how will we decide, are we climbing from here to the top or here to the top? We will be finding what is the minimum cost from this one, if we are going from this step or from this step. Whichever is the minimum, then we are taking that path and then we are going to the top. So to find that, how we can find that, to go at the nth step, we are going at the nth step. Either we are going from n minus 1 or we are going from n minus 2. So that is the two options we can take to take the step to the top. If we are going from n minus 1, so it will be, what we can do is, now we have to find the minimum cost. What was the minimum cost from bottom to reach this step? So that minimum cost plus its own cost, then only we can jump here to finish these steps. First we have to find what was the cost to reach here, and then we will add its own cost to that. That will be the total cost to reach here. Same for this one. So what we are doing in this case is, we are using a table. It's a dynamic programming. We are using a table and we are storing the minimum cost to reach any step. We are starting from index 0. These are the indexes. 3. Okay. So index 0. Because we have given that it doesn't cost us to go to index 0. So minimum cost to go to index 0 is 0. And minimum cost to go to index 1, this step, we don't have to pay any cost either. So that is 0 again. And then to go to step number 2, to go here, what it will be, how we will come at the step 2. It will be minimum cost, how we reach here at step 1, plus its own cost, because if it is taking a one step plus its own cost, so a minimum cost is 0 plus its cost, that is 15. 0 plus 15, then we are reaching at top. We can either come from here or we can come from here. So its cost, minimum cost was to come to this step, it was 0. And then if we are going to this one, then we have to pay this cost, 10. In this case, 15, from 15 cost and from 10 cost, 10 is the minimum cost. Now the path which we will be taking is the 10. We are coming from here because we only have to calculate the minimum cost. So then the recurrence relation at every step will be minimum cost to reach that step, minimum cost to reach this, for example this step, minimum cost to reach this step, plus we are taking it I, plus its own cost, that is from the cost array, its own cost. Sorry, because we are finding the minimum cost at this position at ith index, then we are counting the minimum cost a step before it, which is I minus 1, and the cost I minus 1 a step before it. And then the second option can be, we are coming from 2 steps, we are taking 2 steps, then the min cost at I minus 2 plus the cost at I minus 2, same this one. So I will be writing it up there. So what it looks like is, the recurrence relation which we are calculating every time is, we have to find minimum of, we have 2 options, either we are coming from 1 step or from 2 steps. So it is, we are designing an first, okay, let's start from the algorithm first. We will be creating a table to store all the minimum cost. Create a table, or we can say an array, to store minimum costs. And then the second step, what we are doing is, in the table, we are filling in the positions. So because we know at step 0, at index 0 and index 1, the cost is 0. And then we have to find every time. So what will be the minimum to reach the second step? Like for this one, what is the minimum? Minimum cost. Either we are coming from one step down, that is, we are finding minimum cost at I minus 1 plus its own cost, its cost I minus 1, and the second option which we have is minimum cost on the second step, second down step, I minus 2, and its own cost at I minus 2, cost I minus 2. So either we are going from this position to the top, or we are going from this position. So whichever the cost is the minimum, then we are finding minimum of these two. That is the path we are taking, and that will be the next minimum. So this is the recurrence relation we are calculating, and we are filling in the array. So let's create an array here. Let's name it min cost. Min cost equals to new int. Its size we are taking as the cost. So its size will be 1 plus the cost array, because we are counting it a number beyond it. So one more than this one. Cost dot length plus 1. This will be the size of our array. And then what we are storing in our array is min cost at a 0th position. So it is costing us $0. And then the second given thing is min cost at first index. We don't have to pay anything. It is 0 as well. Then for the rest of the steps, we have to find the values, how much can be the minimum cost. So for int I equals to, we are starting from index 2 because we already know up to index 1, I less than equals to, it will be cost dot length I plus plus. So it is for we can find here, we will be taking a variable here. Let's take int. If we are taking one step, take one step, we have to make a decision. At the end we have to find the minimum of the two steps, two options which we have. If we are taking one step, how we can take one step is in the min cost array. What is the cost or at I minus 1, where we are at now? So a step before it plus its own cost, and then the second one, second option is we are taking two steps to reach there. The two steps can be min cost I, from two steps we are coming to that position with adding its own cost. We are adding its own cost because first we have to pay the cost, then we can take the step I minus 2. So these are the two options which we can take. Now which one we will be taking? We are which one we will be putting it into the array. We are only adding into the array at ith position whichever is the minimum. Math dot min. Now min from take one step, comma take two steps. So whichever is the minimum, we will be adding it into the into this array. And at the end, once our whole array is filled with all the minimum costs, then we can find the cost that is taken to reach at the very top. We can just return that, return min cost. The very last step will be min cost dot length -1. This will be the very last step, and we are returning the minimum cost at that step. Accept it. Let's submit it. Okay, so it is submitted. In this case, the time complexity will be O of n, as we are using a for loop, which is we are looping through all the costs once, and the space complexity in this case will be O of n as well, because we are using an additional array which is storing the minimum cost. So that is also of the length of the costs array. So space and time complexity are O of n both. So we can solve this problem in linear time and linear space. Thank you so much for watching. See you in the next video.